Hello students, good afternoon and good evening to you all. So in this presentation content, we are going to be looking at the areas of emphasis together with the main errors, together with correcting them, done in mathematics, both pure and applied mathematics. So this session is strictly for Form 6 candidates and it's going to be distributed to the members and later it will be distributed to the public via the YouTube platform. So this is going to be a mathematics first session involving both pure and applied mathematics, and you're going to be looking specifically at the areas of emphasis and where we need to correct some mistakes when you're presenting our work. So this first session is presented to you by Better Days Learning Platform under the guidance of Algebra. So to reach me out, you'll be using the following contacts. However, these days we are very busy, so if at all you're having issues, you make sure that you present it in the academic platform that we made for this channel specifically. So as we start, we are going to look at the paper setting of both pure and then applied mathematics. So if you look at the papers are going to be, this year is going to be closing haute curriculum, or is going to be closing the way papers are going to be individually set. So under algebra, we are going to look at section A to contain 2 numbers, and then section B to contain 2 numbers. Now the guidance I can give you here, if at all you have corrected enough mocks papers, you can easily spot the algebra topics of interest according to the topics that have been repeated by the several mock bodies. But however, that doesn't guarantee that the topic is going to be examined, but it has a higher point of view in terms of examination or in terms of examiner's interest. So algebra is going to be the widest topic, is the widest topic in pure mathematics, and is going to be examined, or is going to carry 2 numbers in section A and then 2 numbers in section B. And then from there we shall go to calculus, where we mainly look at differentiation together with integration with their respective applications. So this one we are going to expect 3 numbers, or we get 3 numbers in section A and then we get 3 numbers in section B. And you're going to look at the contents of each of 8 of the topics that have been stated here. So we shall go to vectors, where most of the mistakes are observed and where most of the students lose marks from due to its strict observations, which we are going to look at later. So for vectors, we shall get 1 number in section A and then 1 number in section B. And then we shall go to trigonometry, which will give us 1 number in section A and 1 number in section B. And then later we shall look at geometry. Geometry, we are going to get 1 number in section A and then 1 number in section B. So this is the paper setting for pure mathematics. Now let's look at the paper setting for applied mathematics. Now if you are to look at applied mathematics, we are going to get 3 numbers in section A and in section B coming from statistics and probability. Now this is the area of interest of most of the learners, and some of you tend to neglect mechanics. Now you find out that if at all you have neglected mechanics, you find out that you're only going to get 6 numbers in section A and in section B in total. But that doesn't guarantee that you're going to be in position of doing those numbers appropriately, because most of the statistics numbers, especially in section B, they carry 12 marks and they are all uniform. So if at all you make a mistake in part A, you're going to lose all the marks in the corresponding parts. So we also have numerical methods, where we mainly have errors and NRM. So you'll be getting 2 numbers in section A and then 2 numbers in section B. And then we shall look at kinematics, where you're going to get 1 number in section A and then 1 number in section B. Then statistics is going to give us 1 number in section A and then 1 number in section B. So we shall go to dynamics, and dynamics is going to give us And dynamics is going to give us one number in section A and then one number in section B. So this is going to be the paper setting for both pure and applied mathematics. So as you're making your summary, this is how your revision in these last days should flow. So you should make your revision, or you should table down your revision according to the way these topics have been summarized in this table. So that at the final day, if at all you're revising applied mathematics, 1 week before exams, you must be at dynamics. But use this flow to make sure that you are mastering all these topics. So let's start with the pure mathematics content. So under pure mathematics, we say that we are going to have algebra to constitute a vast majority of what you are going to have in the paper. So with this, you must be good at simultaneous equations. Now, simultaneous equations, where we are having most errors, are coming from simultaneous equations with quadratics. Usually, these equations are given. For example, 3x plus y is equal to 2. And then we also give you x squared plus 2xy. And then plus 4y squared to be equal to 1. So these equations, these simultaneous equations which involve quadratics, by quadratics I mean having squares of 2 or having powers of 2. That's what quadratics mean. So we say that to approach such solving of these simultaneous equations, you pick the equation that has no quadratics, and then you make one variable the subject. So for this case, you make y the subject, and then you end up with y to be equal to 2 minus 3x. So use the equation which has no power to make one variable the subject. Then after that, you come and you substitute it into the equation which has powers. So that's how we approach simultaneous equations with quadratics. The others are pretty basic, whereby we don't have a lot of errors done by students. So if we go to polynomials, we are facing a challenge of expanding the brackets. And if you look at your logbook, you're allowed to go with your logbooks. Your logbook has provided you with all these expansions. So most of you, before you sit for your examination, you make sure that you are very good at expanding these expansions. So that's where polynomials comes in algebra. We are going to look at the challenges that are going to be faced in each and every subtopic. Then you also look at binomial expansion. So binomial expansion, here what you should notice, you should note what number of terms means. If at all we tell you to the fourth term, that means that x power 3. If we tell you to the fifth term, that means that x power 4. If we tell you to the third term, that means that you're stopping on x power 2. Reason being, when you're counting number of terms, we count starting from power 0. So that's why in the binomial expansion, you start with 1, because any number power 0 is the same as 1. So x power 0 is going to be the first term, and then x power 1 will be the second term, and then x power 3 or x power 2 will be the third term. 1, 2, 3. And then x power 4 will be the third term. So that's how it goes. You need to understand the difference. So x power 3 means the third term. X power 4 means the fifth term. So most of you mess up with the expansion and then you get 0 marks from there. Now remember, in binomial expansion, when you're getting the values, after expanding, you don't forget putting plus dash dash after using an equal sign, because these are estimations. So if at all you use an equal sign, you make sure that your expansion ends with plus dash dash, as it is in the logbook. But if at all you use an approximate sign, then you are free to neglect this. So take note of that. Now the other topic is going to be indices, sets, and logarithm. This one is pretty okay, but mostly you are being challenged by indices. Now remember that differentiation and integration, you cannot survive indices. So I made a full video about indices. You make sure that you review that on the YouTube platform. The next one is going to be series. Now series, these are going to constitute arithmetic progressions and also geometrical progressions together with compound interest. Now, compound interest is where we tell you that maybe Mr. Yusuf invested 700,000 in a bank and is not going to withdraw it after 4 years, or we just tell you the years. He invested at the end of 2004. What money will he have at the end of 2007? So you need to understand this. When they say at the end of 2004, you need to start counting the number of years from 2005, because the interest comes at the end of the year. If you tell you at the beginning of 2004, that means that you need to start counting the years starting from that very year, because at the end of that year, we expect an interest to come. So you need to take note of that. At the end of the year and at the end or at the beginning of the year. When they say at the beginning of the year, you start counting from that very year. And when they say at the end of the year, you start counting from the following year, because an interest comes after 12 months. So you need to understand that. And some students mistake that by getting 2007 and then they subtract it from 2004. Now you often find that you're going to lose marks for that, because you have to do it manually. The years are not many, so you make sure that you count manually. The subtraction is going to take away the logic and you end up failing. So you find that such numbers of compound interest are appearing mostly because students are making mistakes. And remember what I told you earlier. I told you that the numbers that you see appearing often are the numbers that you are making most mistakes on. So examiners keep bringing them back to test whether the teachers are correcting those mistakes. So also in algebra, you're going to look at complex numbers. So complex numbers, mostly the examinable ones are mixed with squares. So you make sure that you're very good at geometry involving squares. Then you also look at permutations and combination, and then later we look at inequalities. But permutation and combination was brought last year, so this year we are least expecting it. And then inequalities are also a good area of examination. However, in section B, inequalities tend to be mixed with circles or with curve sketching. So make sure that if I tell you to do a number of inequalities, you make sure that you're also very good at you also make sure that you're very good at geometry, especially differentiation involving curve sketching, because the two are going to be mixed. Now under this, you must focus at the area of real roots. Understand how to use the discriminant, and with the discriminant I mean the area and the square root and the bulldozer method. So b squared minus 4ac. Understand how to use the discriminant in determining the real roots, and also in determining unreal roots, and also in determining two equal or repetitive roots. So you need to be good at that, because it's very examinable. If at all we are setting curve sketching, that will come. And if at all we are setting inequalities in section B, you will not miss out that. Together with other parts of geometry, especially geometry 2. So let's look at the challenges that are going to be involved, or that we usually see in algebra, but I've mentioned most of them. So one is going to be incorrect calculation of the quadratic equations and substitution into the bulldozer method. Now some of you, if at all you're using y, if at all in your quadratic you're using y squared minus 2y, then plus 4 is equal to 0. When you're substituting the bulldozer method, which is present in your logbook, do not say x is equal to. Use the same variable that you're having in your quadratic. If you're having y, use y, and then you substitute everything into the bulldozer method. Now in the substitution into the bulldozer method tells you negative b. So for you to get a substitution mark here, you need to properly substitute the variables into that equation. So if it's negative b and here you're having negative 2, do not make that calculation in the head. You simply come and then you substitute it into the equation. So the negative b, the negative is present here, and then your b is negative 2. And then plus or minus, when you're writing b squared, you make sure that you put this value, which is negative, in brackets, because this square has to affect both the negative and the 2. So do not take away the negative, or don't say negative 2 squared, because this is very different. And most of you are making this mistake. So minus 4ac. So this one is very okay. You multiply with your a, which is 1, and then with your c, which is 4. But substitution, for you to qualify for substitution mark, you need to be very careful when it comes to this b. The negative on the b has to be seen, and then you make a substitution for your value of b. If at all the value of b is negative 2, you put it here. But don't calculate it in the head, and then you say it's going to be positive 2. When you do that, you don't get the substitution mark. And you have also said that when you're handling b squared, when you're substituting, you make sure that you put the negative inside the bracket, and also you put the squared outside the bracket. So it's a common error when it comes to calculation using the bulldozer method. And then after substituting into the bulldozer method, then you are free to use your calculator to get the marks that are going to the values, or the 2 values of y that are going to be required. So proceeding, we are going to go to the challenges that are going to be involved, or we are going to look at challenge 2. One is going to be forgetting the negative sign on the sum of roots. Now usually, after doing polynomials, when you say alpha plus beta, we tell you that it's going to be equal to negative b, and this goes back to something I've been mentioning earlier. So if at all you're having your quadratic to be x squared plus 2x, and then plus 0 or plus 2 is equal to 0. When you're getting sum of roots, the negative is there by default. So most of you forget it. So you put the negative, it's there by default. And then you pick the coefficient of x in the quadratic equation. If it's positive 2, you write positive 2. If it's positive, you may leave out this positive sign. If it's negative 2, you make sure that you put here this negative by default, and then you write the coefficient of x. If at all it was negative 2, you write negative 2. And then later it shows that this negative, which was initially present, multiplies the value inside the bracket to give us a positive 2. But the negative is there by default, and most of you forget to include that negative. So the next challenge is going to be inadequate knowledge on completion of squares. And what I mean by that is that some of you may complete squares, but you don't know how to get the minimum and maximum values. So I made a full video on that. I'm not going to say a lot of explanations from here. So make sure that you review completing squares. This is a very common problem by many, or by majority of these students. So I made a full video on that on the YouTube platform. So make sure that before you sit for papers, you are very good, or you are very conversant with completing squares, because it's a very common topic of examination. And we say that the topics that are very common to be examined are because students are very weak under that particular area. So make sure that you review that area of emphasis, because also in circles that knowledge is required, also in further geometry or geometry 2. Now proceeding, we're going to look at expanding to the required number of terms in the binomial expansion. I've already talked about this. Understand what the fourth term means, and also what x power 4 means. X power 4 is not the same as the fourth term. I've already explained that when I was talking about it here. So the other thing is going to be improper use of the equal and approximate signs. Now during estimations, like I told you, in binomial expansion, when you're using approximate sign, you make sure that you don't include the plus dash dash sign at the end. If you're using the equal sign just like it is in the logbook, then make sure that also, just like the logbook puts it, you end with the dash dash sign at the end. So you need to be very attentive with the way you are using the approximate sign and the equal sign when you're dealing with binomial expansion. The other one is going to be lack of enough practice using the log tables. Now some of you don't know how to differentiate between cumulative tables of binomial expansion when you're dealing with binomials or you don't know how to find formulas to deal with algebra when it comes to the final papers. Some of you are not used to using the logbooks to find those methods. Now you find that in geometry, especially with algebra, especially with geometry, all the methods are going to be given in the logbook, and all the questions that are going to be examined in geometry, the methods for finding out those questions are going to come from the logbook. So for geometry, whenever I say geometry number, we refer to the logbook to get the method. And also, if at all you are reading any of the values in the log tables, then you need to differentiate between individual values and also cumulative values. We shall talk about this more in applied mathematics. So the other challenge is going to be incorrect substitution of the methods involved in series questions. Like I'll still emphasize this to the use of the logbook. If you look at all the series questions, arithmetic progressions, and also geometrical progressions, all the methods are given in the logbook. That's why we don't give method marks in pure mathematics. So it's your ability to go and pick a logbook and then you look for the appropriate method to use. Understand what the nth term formula is, and also understand and distinguish it from the sum of nth terms. So that's why we are having main challenges from. Students are combining the method of nth term with the method of sum of nth terms. So make sure that you get a clear difference between those two elements or components. Now next under this, we are going to look at the calculus. Now for calculus is going to involve differentiation 1 and its applications, where you look at small changes, rates, and also maximum and minimum. And also under this, we can also look at curve sketching 1. Now the next one is going to be differentiation of exponential and natural logarithms. I made a video about this. The next one is going to be differentiation of trigonometrical functions. Now this is very important. You need to understand what you get when you differentiate cos and what you get when you differentiate sine, because it's very important in integration. Remember that integration is a mixture of both differentiation and integration. Differentiation comes when you're changing variables, and the integration comes after changing variables. Now we're also going to look at the integration 1, which involves volumes and also areas of different curves. Now this is a very common challenge because we don't have very good teachers to elaborate this properly to the students. However, it's less set in the examination for the same reason. The next one is going to be integration involving partial fractions. Now students, these numbers, when they're coming in paper 1 or in pure mathematics, they're going to come in section B and they're going to carry 12 marks. So you need to understand how to solve the 3 different types of partial fractions. I made videos on that this year. How to solve the different partial fractions and how to approach either of them differently. And then lastly, we shall look at the differential equations. Now this year we are mostly expecting the one-day differential equations. But that doesn't mean that you should neglect the other solving equations, the A's. You also approach them and discuss them. Now differential equations, these ones are a must to be done by any student who is wishing to get a D1 in pure mathematics, because they are the easiest if at all your integration and partial fractions are done or are mastered properly. So challenges, if you have to go to the challenges, so differential equations, you put a good emphasis on them because they are very easy to understand and master within a very short period of time. When I get time, I'll see whether I can make a video about it and then I'll put it on the platform. So if you look at the challenges, when you're handling implicit functions, you neglect to show that you are going to differentiate. And implicit functions are going to be in the following format: x squared plus 2xy, and then plus 3y squared, and then we tell you that it's going to be equal to 4, or in a constant, or 0. So in handling the derivative of these implicit functions, you are supposed to, your second step, the first step, you first rewrite the question. Then the second step, you are supposed to show us that you're going to differentiate both sides. So you write all these terms on this side and also show that you're also going to differentiate the other side in respect to x, whichever the constant may be. So this step is missed by most of the students, and the previous year it led to cancellation of most of the students, 2019 or 2020. If at all you don't show that you're going to differentiate both sides, we don't know what you're going to be doing. And also the other common error comes from the product rule. If you're having negative 2xy and you're going to differentiate this, you differentiate this first and you get 2x, and then plus or minus. When you're doing a product rule, you make sure that you introduce brackets, simply because the sign which is always here affects what's going to be got in the product rule, and that's what most of you miss out and then you lose marks. So when you're handling this product rule, which involves two variables, x and y multiplying each other, you make sure that you introduce a bracket to prevent this sign, or to allow this sign affect what is in the bracket, because it's a full function on its own. So the sign which is next to it is obviously going to affect what is present in the brackets. So you pay attention to the implicit functions calculation or differentiations. So first we say that your second step, you must show that you're going to differentiate on either sides. And the next one, we say that when you go to product rule, you introduce a bracket, because the sign near that bracket is going to affect what you're going to get in the product rule. So you must have a bracket on that step. Now the other error is going to be leaving out the x on integration. So this is a main problem, whereby you can come and then when you're panicking, let's say you're saying that 2x plus 1, and this is done especially in applied mathematics under continuous PDFs or PDs. You say this, and then plus integral of maybe 2x, and then plus integral of maybe 1, and then later you say dx. So you find that you are missing out the x on both of these integrals. So if at all this happens, we don't consider this integration. An integration is only valid if at all you are showing us what you're integrating in respect to. So if at all you say integral of 2x plus 1 dx, and then on the next step you give us this is going to be x squared and then plus x, this is valid. You are showing us that you are integrating in respect to x. But here you are not integrating in respect to anything, so we don't expect any change. So it means that if at all you forget this dx, you don't qualify to achieve any mark in the subsequent steps. I hope that is clear. Now the other thing that may lead to loss of accuracy marks is leaving out the constant c after integration, especially when you're handling integration involving no limits. So with that I mean that after integrating, if at all you don't have limits, if at all you don't have either from 0 to 1 or from any number, you make sure that after integrating, you end with the constant of integration. Now there are some instances where you are going to integrate twice. So if at all you have already used the constant of integration c, then you can use another constant, which may be k. And then you put a comma, and then you say that where k is going to be the constant of integration. If at all you have done two integrations at once involving different constants, you make sure that you specify the other constant by putting a comma and then saying that where k is going to be the constant of integration. Now the other challenge is going to be from failure to come up with a suitable substitution when handling integration questions. Now this is only going to come by practice. I can't tell you a specific method to approach the various integration questions, but make sure that you practice about 5 numbers every day before you approach your examination if I told you how to do integration. Now remember that I told you differential equations are must to be done, because here we have less errors and less strictness in terms of examinations marking. So if at all you want to maximize your marks, differential equations are a very good point to start from. But to do this, you must be very good at integration and also partial fractions. So that's why it's a must to practice integration and differentiation every single day. Now the next one is going to be forgetting changing limits during integration. Now this is a very common mistake. So if you look here, after saying that, maybe let u be equal to whichever, let me say cos squared x. If at all you're having an integration from 0 to 1, when you're having a function of x here in respect to dx, this one means that these limits are in respect to dx or to the variable of x. So if at all you introduce another variable, do not introduce these limits again. You either drop them and then handle the next variable, or you change them in terms of the u. Use this expression that you have got, and then you put here 0, and then you put here 1, and then you change them to the du variable. Do not carry limits of dx after changing variable. You either drop them and then introduce them later, or you change the limits and then you proceed with the integration. And this is something that must be properly emphasized by your teachers by practice. Do not bring back limits after changing variable if at all you have not changed them. The next one is going to be failure to compute using radians while tackling integration questions. Now if you look at pure mathematics and applied mathematics, when you're dealing with integration, always change the calculator to radians. Any integration, always change the calculator to radians. Now there are very many things to explain here, or there may be very many inquiries, but for pure mathematics, it's going to be a very rare case for us to give you a trig function which is going to be present in degrees. So if at all anything is not in degrees, in pure and applied, make sure that your calculator is in radians. When you're tackling trapezium rule, make sure that your calculator is in radians. When you're dealing with integration questions or partial fractions, make sure that you change the calculator in terms of radians. Now the next one is going to be failure to change limits and still carry them during integration. We already talked about this. Then the last one under calculus is going to be the emphasizing to practice the third partial fractions every day. And the reason why you're saying this every day, because these are the easiest questions to maximize marks from. So if at all you want to take your pure mathematics to another level, you make sure that your integration, partial fractions, and differential equations are properly mastered in these remaining days. And this can be done by doing about 3 numbers every single day. And after that, you take them for a teacher or to a teacher for assessments. I hope that is clear. So proceeding, we are going to look at trigonometry. Now trigonometry is divided into 2. One we have in trigonometry 1, and then 2 we have in solutions of triangles. Now under this, we are going to go straight into the challenges. Now 1 is going to be failure to list angles that are given in the required range. Now I made a video specifically on finding angles on the YouTube platform. So you go to pure mathematics and then you work on this issue. You need to understand how to provide angles that are present in the required range. I made a video and it was elaborative to all these challenges. So I'm not going to overemphasize that. You make sure that you log on to the YouTube and then you find that video about finding angles on the Better Days e-learning platform. Now the other one is going to be forgetting the plus or minus after finding the square roots. Now here, if at all you're having cos squared x to be equal to 4, or if you're having sin squared x to be equal to 3, when you're finding square roots, when you're saying that sin x is going to be equal to when you're finding square root, the moment you put a square root, we expect your answer to be plus or minus. So for variables that don't have direct square roots, you make sure that your answer is going to be plus or minus root of 3. And then later you handle either sin x is going to be equal to positive root of 3 or sin x is going to be equal to negative root of 3. And then you get the angles according to the value you're having. So for this case, you will say that cos x is going to be equal to, so since 4 has a direct root, we shall say 2. But after finding square roots in pure mathematics or advanced level, the answer must be positive or minus, except in applications of pure mathematics. But other areas, the answer after finding square roots, especially in complex numbers and in geometry, also in algebra, also in trigonometry, the answer must be plus or minus. Do not forget that, because it's examined in each and every paper and in each and every year. After getting a square root, the answer is plus or minus. Now the next one is going to be crossing out trigonometrical functions instead of prime factorizing. Now this is a common instance that is coming back and appearing every year, because students, you are not understanding the objective. So if at all you're having cos squared x minus 2 sin x, if at all you have solved and then you have reached this point, minus 2 sin x cos x should be equal to 0. This doesn't mean that you're supposed to cross out cos x, or you're supposed to divide through by cos x. We do not cross out trig functions. So instead what we do here is we prime factorize. We do not cross out unknown variables. Even if it was x, you do not cross out unknown variables. What you do is prime factorize. So for this case, we shall have cos x into bracket to be cos x, and then minus 2 sin x to be equal to 0. So this means that either cos x is going to be equal to 0 or this bracket is going to be equal to 0. Similarly, if you're having 2x squared minus x to be equal to 0, you do not cross out x. You prime factorize out the common unknown variable, and then you remain with 2x minus 1 to be equal to 0. So from here, it's going to be either x is equal to 0 or 2x minus 1 is going to be equal to 0. So make sure that you are very observant when it comes to this, because it's highly examinable. The next thing is, when you're finding square root, it's always plus or minus. It's not only a positive value. We always get two variables, plus or minus the value that you're going to get. Then the next one is going to be conversion or failure of converting degrees to radians. Now you often find that, especially in complex numbers, when you're dealing with De Moivre's theorem, you'll find that the ranges that are given are going to be in terms of radians. That means you see pi. But most of you do your calculations in terms of degrees. But for you to get the accuracy mark, your answer must be in terms of radians. So we made a simple application for that, and we told you that 1 degree is going to be equal to pi over 180 degrees. So this should be in your head. That means that if you want to convert 45 degrees to radians, you're supposed to get pi divided by 180 and then times 45. So you find that 45 is 1. When you divide by 45, 180 is going to give you 4. So you find that 45 degrees is going to be the same as pi over 4. So the objective, or the method of converting degrees to radians, we are going to use a simple formula which is very easy to remember, especially in these remaining days. So you simply say that 1 degrees is going to be the same as pi divided by 180 degrees. And you are going to be using this substitution to simplify or solve all other equations or other numbers that are involving changing degrees to radians. And to change radians to degrees, you use the same method. You simply make pi the subject, and then you proceed. So if you look at vectors, Or if you look at the next thing, which is going to be vectors. For vectors, the main reason why we fail vectors, remember vectors is present in both pure mathematics and applied mathematics. And the main reason why we are failing vectors is leaving out notations. Every vector must carry a notation. Every vector. And this is very emphasized because vector involves both direction and magnitude. So if at all you're writing a single letter, you put notations at the bottom. If you're writing two letters, let me say OP, OPB, both in pure and applied mathematics, you put arrows at the top or you simply put a dash to show direction. Without direction, you cannot get any mark from vectors. So you need to be very, very careful when you're handling vector questions. We shall emphasize this when it comes to applied mathematics. But when it comes to pure mathematics, you make sure that you do not forget notations, especially when you're dealing with scalar calculations. Scalar calculations are these ones that are done linear. The I must carry a notation at the bottom, the J must carry a notation at the bottom, also the K must carry a notation at the bottom. Now the next thing to emphasize here under vectors in pure mathematics is going to be cross product. Now in pure mathematics, we do not have cross product, we only have dot product. Cross product was pushed to applied mathematics. So these questions that are coming back or that are very frequent involving you finding the vector equation of a plane, most of you are using cross product. A book which involves this Excel in pure mathematics without tears, that book has provided a very good valid method of approaching finding equations of vectors of the plane without using cross product, because cross product is no longer in the curriculum of pure mathematics. So the moment you use cross product anywhere in pure mathematics, understand that you're going to lose those marks. Strictly, it's going to be dot product. So make sure that you put an area of emphasis on that area. The other one is going to be leaving out the negative sign while finding the magnitude. Now I've already talked about this. If at all you're having, let me say, column vector of -2, 3, and -2, when you're finding magnitude of this, when you're putting these things under square root, you make sure that everything is in the bracket. The digits that contain negative, they must be enclosed in the bracket. So that is going to be -2 squared. This is very different by saying -2 squared. This is wrong. And this is where you're going to get your work cross from. So make sure that if you're having a negative digit, it must be in the bracket when you're finding its square. That's the correct presentation. The other one is going to be inadequate knowledge of the trigonometrical function to use when you're finding angle between a line and a plane, and also a plane and a plane and a line and a line. Now for this, I made this very simple for my students. If at all you're having uniform things, if at all you're having a line and a line, you'll be using cos. If you're having a plane and a plane, you'll also be using cos. But if at all they have mixed them, line and a plane, for this we are using sine, and the formulas are available in the mathematical logbooks. So if you're finding the angle between a line and a plane, which are mixed, you'll be using sine theta. If you're finding an angle between a plane and a plane, you'll be using cos theta. And if you're finding an angle between a line and a line, you'll be using cos theta. If at all they are uniform, you're using cos. If at all they are mixed, you're using sine. It's as simple as that. So lastly, under geometry in pure mathematics, we're going to look at the failure to use the logbook in finding appropriate geometrical methods. I told you whenever you are given a geometry question, you always open your logbook, which is always provided to each and every student. You always open your logbook and then you find the appropriate method to use on that particular question. The other one is going to be limited knowledge on circles, especially dealing with completing squares and solving 3 simultaneous equations involving squares. So you also put a point of focus on that area. So that was it for pure mathematics. So now let's start applied mathematics. So applied mathematics, we're going to start with mechanics because this is what disturbs you the most. Now remember I told you that under these areas, you're going to get one number. So if at all you're following the other revision criteria I've told in the beginning, this is the way you should break it down. So in day one, you should be handling two topics. Or in day one, you should handle one topic from kinematics and then one topic from statistics. In other words, you should handle it that way. If you are revising motion in a straight line, you revise it with resolution of forces. If you're revising vertical motion under gravity, you make sure that you combine it with equilibrium of a particle. If you're revising projectile motion, you also revise some bit of moments and couples. And if you're revising relative motion, you also revise it with equilibrium. So this may take you 1 week or 2 weeks. But this is the content outline. So for you to break it down, since the topics are complicated to most students, you need to break it down, and then you need to, if at all you have not covered this, you may neglect relative motion. And also, so for this under kinematics, you must master these three because they are very commonly said. When it comes to statistics, you must master resolution of forces and moments and couples. You may neglect the equilibrium of rigid bodies, but you must take the first three. If at all you are weak in those areas, then you need to find a discussant or a person who is good at mathematics in your class to guide you out. So take note of that. Now the other common area of interest, they are going to be dynamics, still under mechanics. So under dynamics, we are going to have the Newton's laws of motion, and this is going to involve pulleys. F equals to ma, the resultant force to be equal to ma. This one is commonly said and is advisable for all students to understand it. Also, so these two are mainly said in applied mathematics, but also work, energy, and power. This involves mainly pure math knowledge. So if at all you're a student who is very good in pure math, you make sure that you review this topic as soon as possible, because it's the same concept, just differentiation and then integration. Then you also understand momentum and how to use momentum. Momentum is commonly said in section A, so it's very hard to survive this topic once it sits. You need to understand how to use momentum, but to understand this better, it's mainly by physics students. So if you're a biology student, you make sure that you're very good at discussions involving momentum with the biology students. Now the areas of emphasis under mechanics, one is going to be reading the question twice. Now if you find that most of the mechanics questions, units are going to be different on each and every variable given, and also the accuracy values are given at the end. So most of you panic and then you start the question without reading it fully. So for mechanics, you need to be a little bit and extra careful. Any mistake done in mechanics can lead to cancellation of the entire number. So when you're approaching mechanics, read the question twice and ensure that all the values given are having uniform units. If it's centimeters, every value given must be having centimeters. If it's meters, then every value given must be in terms of meters. Then the other area of emphasis is going to be the diagrams. Now for mechanics diagrams, the moment you draw a wrong diagram, you are going to get the entire workings wrong, however correct you may be, because we don't expect you to give us a map of something taking us to Kampala and then you are going to Gulu. So that's how mechanics is interpreted by examiners. So make sure that your diagrams, the direction of forces are properly represented and your calculations are in line with what you have presented in your sketch. The diagrams must be big enough for you to attain a bonus mark for that diagram. So you need to take note of that. All diagrams must be drawn using a ruler, except the pulleys that you may draw using your free hand. The direction of forces must be well indicated. Other than that, you cannot get a bonus mark for that diagram. And also, your calculations are not quite valid if at all you are not dealing with, especially when you're dealing with Newton's laws of motion. the direction of forces must be properly indicated, with the diagrams being properly well presented, big enough for the examiners to see. Now, here is going to take me to the emphasis of using a pencil. Use a pencil to draw the diagram that you need. After getting the diagram that you need, ensure that you use a pen to sketch or to put it down. The reason why we are encouraging using pens in drawing diagrams is because the papers are going to be stored before they are marked. And during the storage of those papers, some of you use pencils that are faint. That's why if you don't have a deep dark pencil, you make sure that you put your diagrams, your mechanics diagrams, in terms of ink, because ink cannot get diminished over time. So you make sure that you put your diagrams in terms of ink. In fact, it's ink which is advisable. You have seen the marking guides that are done, and the marking guides that we distribute out. Everything is in terms of ink. There is no pencil anywhere. So it's better to put all the workings in terms of ink. The pencil must be used to give you the correct sketch. In case you hope to make any mistake, then after using the pencil, you write or you re-sketch down all those diagrams in terms of ink after being sure of the diagram and after being contented of the diagram that you have represented. Now the other one is going to be acceleration due to gravity, which is G. Now this is a very common mistake with physics students. In mechanics of applied mathematics, we expect the acceleration due to gravity to be strictly 9.8. Physics students do not wiseacre and put it to another variable. If at all is not specified, strictly use 9.8. Of course, many students of mine who are doing physics giving me other variables. When the value is not specified, strictly stick to 9.8 as the acceleration due to gravity. Unless the question has specified it, then you can push it to 10. But if at all is not specified, even in the beginning of the paper, under the instructions, you'll be given that acceleration due to gravity is going to be 9.8. So you make sure that you don't state any other variable other than that. Now the next thing is to, when you're dealing with vectors, especially when you're dealing with this topic, work, energy and power, integrating and differentiating, you make sure that you're using column vectors to prevent losing marks. If at all you're using scalar vectors, then you make sure that the I, the J, and the K are all carrying vector notations for you to avoid losing marks. But vectors, I once again emphasize this. You make sure that you have notations. So the variable that is equating to this column vector must carry a vector notation. Without vector notations, the entire question is going to be marked wrong. So you'll be losing all the 12 marks the moment you leave out vector notations. When you're dealing with vectors, you need to be extremely careful. They look like simple questions, but we are very strict on their marking. So you make sure that you present the notations as required by the examiner, because in vectors we look at magnitude and direction. So it's those notations that give direction in your work. So if at all you don't have direction in your work and you are claiming to handle vectors, then you're handling another topic which you don't know. So you will be crossed the entire question in case you leave out notations. So with that, if at all you are doing a vector, if at all you're going to do any vector question, I strongly recommend to start with this question. And after doing that question, you make sure that you strictly and closely revise it to ensure that you have presented all the notations that are required. Now the next thing is going to be about numerical methods. Now when you're dealing with numerical methods is going to constitute the following subtopics. One which is commonly said is going to be interpolation and extrapolation. Now for this one, the point of advice or the point of emphasis I have on this is that you actually see your final answer must be accurate. And with this I mean that after writing your final answer to 4 decimal places, For you to get the last mark or the final mark, you make sure that your final answer is in terms of the accuracy of what is present in the tables. If at all what you have in the tables has been given to 3 decimal places, then you make sure that after putting your 4 decimal places, you make sure that your last answer is also in terms of the number of decimal places of what has been given in the table that you're going to linear extrapolate from or linear interpolate from. I hope that is clear. Now the next one is going to be errors. Now errors, what I want to emphasize here, you need to take note that errors will never be in percentage. So some of you, when you tell that an error of 2% was made, you assume that the error in x is going to be equal to 0.02. This is wrong. Error will never be in percentages. This percentage is given according to a certain variable. So we can say that an error of 2% was made in the length. That means that the error, for you to get the error, if at all an error was made in the length, let's say the length is L, changing the length of L of 2%, that means that it's 2%, which is the same as 2 over 100 of the length. It's not 0.02, it is 2% of the length. So that means that to get that error is going to be the same as 0.02L. So the error is this. It's not, the error is not, error will never be in terms of percentage. When you give a percentage, we will attach it to always to a certain variable, both in pure and applied mathematics. An error will never be in terms of a percentage. So you always use that percentage to find the error in terms of the variable that has been attached to it. So in pure mathematics, this is going to be very common and very evident in small changes and applications of differentiation. Now the other thing under numerical methods, you're going to look at multiplication coupled with NRM, which is also known as Newton-Raphson method. We're going to talk about this later. We can also look at the flowcharts. We're also going to emphasize this more later. So starting with the challenges, with accuracy, we'll look at the failure to attain the accuracy marks if accuracy is unspecified. Now, if accuracy is unspecified, in mathematics, both pure and applied, we are strictly using 4 decimal places, except on the angles. For pure mathematics, angles must be strictly to 2 decimal places. Angles must strictly be to 2 decimal places. Now, in mechanics, in applied mathematics, it may be okay to put it to 1 decimal place, but in pure mathematics, we need angles to 2 decimal places. The other thing is failure to interpret this expression f of x to be equal to 0.22 being the same as f prime of 0.22. So this means that you're finding the value of x when f of x is the same as 0.22. So you take note of that. So the other note we say that is going to be that all errors, all calculated errors. If you find in applied mathematics, you have told you to calculate errors, any number of errors, whether we have given you 6 marks or 7 marks, the final answer must be positive. We don't have any calculated error in mathematics to be a negative. So you make sure that all the calculated errors are positive. If you have not got a positive, then you need to review your working, or you need to repeat that particular working. Now the minimum and the maximum values may be either positive or negative. Those ones are very okay. And then when you're asking you for the range, remember that the range is the same as interval in applied mathematics. When you're setting the range or the interval, you must strictly use square brackets. Other than that, you are not going to be marked right. So square brackets, minimum value, comma, maximum value, and then square brackets. So both the interval and the range must be enclosed in square brackets. However, for some of you are being taught to use inequalities. That is very okay. If you're using inequalities, you may use the curved brackets. But if at all you're going to use a comma, then you must strictly use square brackets when you're presenting your range or interval. The next one is going to be, if at all the question is seeking for limits, then you must state those limits onto separate lines. So you start with the upper limit, you state it on a separate line, and then on the next line, you also state the lower limit. They must be stated separately. Do not separate them using commas. You lose the accuracy mark. The next one is going to be the Newton-Raphson method. Now this one is pretty preferred by majority of the students, and you don't have a lot of concerns when you're marking it, except when you're dealing with roots, especially when you have got your root. You make sure that if at all the accuracy in the question is telling you to 3 decimal places, then you make sure that your calculations are 4 decimal places or 5 decimal places. Do not make calculations of NRM in terms of the accuracy that is required by the final answer. You make sure that you are above by 1 or 2 decimal places, but it's more better to be above with 2 decimal places. So if at all the question wants the accurate answer to be to 3 decimal places, then you make sure that your calculations are to 5 decimal places. Then when you're handling derivatives, f of x, before you substitute in the Newton-Raphson method, do not include a subscript of n. So if at all you're handling your function, do not say f of x n. Do not put that subscript of n. You find your function and then you also find the derivative without that subscript. And then when you're substituting into the expression or into the formula or into the method, that's when you include the substitute of n. Now all flowchart steps must be properly connecting. Now with this, when you're handling flowcharts, some of you have a tendency of leaving a gap and then drawing another shape. Now the reason why it's called a flowchart is representing a system. If at all these shapes are not connecting, all the 3 marks that would have been awarded for your work are not going to be considered. You are not going to get any mark simply because it's not a flowchart anymore. So all the shapes must be connecting. You need to use a ruler to connect the shapes, and you need to understand the appropriate shapes that are supposed to be used on each and every step. Now the dry run must have strictly 2 columns. Do not mix the dry run with words. So some of you have a tendency of writing the first column numerical values, second column numerical values, and then you add the third column with yes or no. Avoid that. This is going to lead to a deduction of 1 mark upon what you're presenting. So when you're presenting the dry run, you make sure that it's 2 columns and everything must be numerical. You use your head to understand whether you have reached your final point or you are still going, but do not add the column of yes or no. So make sure that your dry run is in terms of 2 columns. You have seen the marking aids that you have been presenting for the different mock bodies. We didn't add that section of yes or no. The dry run must strictly be 2 columns and it must be all numerical values. When you reach a point where you need to stop, you stop and then you state the final answer, which is required by the particular question. Now another point of emphasis is going to be under statistics and probability, which you like the most. So for statistics and probability, we have elementary statistics, we also have price indices, we have correlation. Now price indices, just like angles, there must also be 2 decimal places. However, some teachers push it to 3 decimal places. It's very okay for as long as you don't go below 2 decimal places. We have correlation, we have continuous random variables, where we look at the PDFs, the CDFs, and also the uniform distribution functions. Then the next one, we look at the discrete random variables. We look at binomial distribution, probability theory involving set theory, and also permutations and combinations. Now for probability theory, nowadays we combine it with set theory, so you may be advised to buy a new set and then you go with the campus for your work to look neat. However, also using freehands is very okay for as long as your work is neat and every variable has been properly represented without any of these lines crossing either of the variables that you have included in your Venn diagram. The common challenges that you're going to look at are going under statistics. The common challenges are mainly with graphs. So one, if you look at the graphs that you commonly examine in probability and statistics are going to be ogives and also histograms. Now ogives must all be drawn using a freehand. We do not use rulers when you're drawing ogives. You need to pay attention to that. So you need to go back and practice ogives, drawing ogives using frequency densities, and when to draw them using frequency densities, and when to draw them using cumulative frequency. You need to be very careful with that. So you need to understand how you can use an ogive to estimate the median mark, how you can use appropriate scale. Now without an appropriate scale or without naming your axes, you cannot get any of the 3 marks that we offer for the graphs. So make sure that your scale has been properly represented at the top right corner. And then your axes are properly labeled. For you to earn any mark, you must be having everything on your graph labeled, especially the axes. And then after drawing your ogive, you must make sure that you know how to find the estimations. UNEB is very good at examining estimations of the middle 40%, and I hope in your seminars you have handled this. So this is not a seminar, I can't elaborate this in details, but make sure that you put emphasis on finding the middle 40% or the middle 60% or the middle 30%. Understand how to find those estimations using the graphs. Then the other one is going to be about histogram. So in a day with histogram, learn how to use the histogram to find midpoints. Learn how to determine whether you are going to use class width as your scale or frequency densities before approaching or before picking up a graph paper. Then here we are having challenges in finding the mode using the histogram, where you find the highest. Some of you don't know you don't know where to get this line from. So you get it from this point and then you take it here. And also you get it from this point and then you take it at the next point of the graph. And then the mid is where we need the value. And then all the estimations that are going to be got on the graph paper, they must be presented on that very graph. For example, part A required you to draw a graph, and then part B required you to estimate a given range. After estimating, you make sure that you go to your graph paper. You make sure that you go to your graph paper and then you find a free area, and then you say that part B, and then you write the estimation there. But after writing the estimation, you make sure that you're having sketches, the sketches of how you got that estimation, and these must be in dotted lines. Now remember, I told you to avoid losing marks, you make sure that your diagrams are all in ink. Avoid using pencils because pencils fade your work. And once the work is unclear, you only see sin, though your subscripts are not returned. So the person marking that is going to put sin. So if at all the chief of the markers or the chief of the examiners doesn't look through your paper, then you are going to lose those marks. So you make sure that you put all your work in terms of ink to avoid your work from fading or to avoid losing marks. So that was it for the challenges under statistics and probability. So proceeding, we are going to look at other points of emphasis in applied mathematics. One is going to be whenever n is greater than 20, then we refer to that as a normal distribution question. Now if at all is normal distribution in section B, and then you are being provided with the value of n, then that means that you are going to use normal distribution involving continuity correlation. Now when you're doing continuity correlation, you do not use equal sign. After doing continuity correlation, either subtracting or adding 0.5, on that step you are supposed to use an arrow sign showing us that you're doing correlation. You should not use an equal sign. So the z values, when you're dealing with normal distribution, must strictly be to 3 decimal places, unless an exact figure is given. For example, if you're having 3, don't say 0.000, just leave it as 3. So if at all you're having an exact figure, you write as an exact figure. But if at all you're having if at all you're having decimal places, then all z values must be to 3 decimal places. Now this is going to put me back to trapezium rule. Now for trapezium rule in the table, when you're having an exact figure, your neighbor is going to mark that exact figure. But if by the higher accuracy or for convenience, you make sure that you present all your work to the same number of decimal places. So for this case, you may write 0.000. If I told you the last answer is equal to 3 decimal places, then your calculations or your table must be 4 decimal places. If you're having a figure or a direct figure or your whole number, then you put it to 4 decimal places, 0.0000. However, if you write it as a digit, you also be marked. But it's better for all your work to be uniform. So if at all you're dealing with a trapezium table, you make sure that each and every digit carries the same number of decimal places like all the other figures that you have written for uniformity. So remember, applied mathematics, they are not marking your content, but they are marking your mistakes. So you need to have less minimum excuses attached to your work. Don't expose your work to gambling, or don't expose your work to probabilities or to bargains which are done by the examiners. So while you're using the mathematical tables, all the probability values stated must be 4 decimal places. If you look at all the tables in your logbook, all the values of probability are 4 decimal places. So if you pick a value there, you make sure that you use the same number of decimal places that you have got from the logbook. So all probability values, especially when you're using a logbook, must be 4 decimal places. Now the other thing is going to be about using a calculator, especially when you're dealing with normal distribution. So when you're dealing with normal distribution or binomial distribution and you're using a calculator, you do not round off unless you're stating your final answer to the required accuracy that has been specified by the question. But when you're still handling calculations, do not round off any variable. The calculator will do that for you. You write the value just like the way you have seen it on the calculator. Now the next one is going to be the trapezium rule. So if you look at the trapezium rule, h can never be approximated. That means that you either write all the decimal places as seen on the calculator, or you write it as a fraction or a whole number. But you can never approximate h. To avoid the moment you approximate it, or the entire number is going to be wrong. So h can never be approximated. You either write it as a fraction, or you write it all the decimal places, you make sure that they are present without rounding off or without truncating. So 2 is going to be that actually stated in the question. If at all the actually stated in the question is 3 decimal places, then ensure that your workings are in terms of 5 decimal places for higher accuracy. Or they may also be 4 decimal places, but they should not be in the same exact accuracy as required by the final answer. Then have your calculator. When I said this earlier, whenever you're dealing with trapezium rule and integration, always have your calculator set to radians. The next one is going to be the approximate sign is used on the trapezium rule method. So on the trapezium rule method, you make sure that you use the approximate sign. Do not forget that. And then in part B, in section B, in part B, when they tell you to evaluate, evaluation means that all of the students in the country must get the same answer. So when they tell you to evaluate, that's when you're supposed to use an equal sign. But when you're dealing with the trapezium method, or when you're dealing with the trapezium calculation, then you must be using an approximate sign. If you're dealing with the evaluation, then you must be using an equal sign. But for trapezium rule method, you must be using the approximate sign. Then 5, or another point of emphasis is going to be when you're dealing with trapezium rule or when you're dealing with NRM, both the approximate and the exact values must carry the same accuracy. And by this I mean that both the final answers in part A and part B must carry the same number of decimal places. So if at all in part A we tell you that your answer must be to 3 decimal places, now in part B we are not going to specify that. So you need to use your part A to understand that after evaluating your part B, when you're having 4 decimal places, then your final answer should also be in line with the accuracy that has been put in part A. So it also must be to 3 decimal places. This is a very common examination trick done by examiners in applied mathematics. So you make sure that you have uniform accuracy from part A to part C when you're dealing with trapezium rule calculations, normal distribution, and also NRM. Those are the areas of emphasis where that trick is examined. The other component is going to be reducing the error. Now, when it comes to reducing the error, if at all the question has used ordinates, you say that by increasing the number of ordinates. If at all the question has used subintervals, you say that by increasing the number of subintervals. That's a trick. Do not, when they have used ordinates, do not use subintervals. And when they have used subintervals, do not use ordinates. Always use the words as they have been used in the question. Now the others, like increasing to or rounding off to a larger number of decimal places, for those ones they are not strict. But if at all the question has used ordinates, then you also talk about ordinates when you're talking about reducing the error, which is always part C. When they have talked about subintervals, also you use subintervals in your answer. So the next point of emphasis is going to be on graphical relocation. So tabulated values must be to decimal places. If at all, remember that if at all we tell you to draw a graph of sin x whatever, we don't expect you to look for 3 decimal places within this small graph boxes or squares. So if at all you're having your table, we expect that the maximum number of decimal places on the values you are going to have in your table, if at all you are going to plot them, they must be to 2 decimal places. This is very important. Then the minimum plottable points or the minimum columns that you must have in this table, they must be 5. So you should not be having less than that. Usually they are between 5 to 8, but mostly they are going to be 7 or 6. But you should not have a minimum of 5. That's the main area of emphasis. You should not have a minimum of 5. And then the axis and the graph must be leveled. The moment you draw your graph, if at all you're having 2 graphs, if at all this is y is equal to sin x, you label it. If you don't label it, you're going to use the marks for the graph. And also label this graph, y is equal to cos of x. Then the scale should be uniform and should be well stated at the top right corner. And with this I mean that if at all you're having 0.2 to have started, you make sure that you are increasing in that range. 0.4, 0.6, 0.8. Don't come from 0.2 and then go to 0.8. So the scale must be uniform. If at all you are dealing with 0.2, go on adding 0.2. If at all you are dealing with 2, go on adding 2, 2, 2. Now starting, your graph is not a must that you should start from 0. You may start on any variable that you need, provided your scale and the space you're having on the graph is going to accommodate your graph. Then the estimations made or the estimations asked in other questions must be stated on the graph paper. I've already talked about this. If at all in part B you're asking for to estimate this at a given value, you're supposed to come and state that value on your graph paper. You say that part B, full stop, and then you say your value on the graph paper in any space that you have that is free, because the examiner who is marking that graph is the examiner to mark the estimations, and that examiner is specifically focusing at the graph papers, so you may not have time for the answer sheets. So you make sure that you present all your estimations on the graph paper. Now let's look at accuracy in mathematics. So specifying conditions, so specific conditions, especially significant figures and decimal places, must be properly practiced by students in these remaining periods. Now for high accuracy, students are advised to use fractions. Then learners, we we especially advise this in pure mathematics. Avoid leaving sides in the denominator. You cannot get a naturalist mark if you're having a side in the denominator. So to solve this, you must rationalize. If at all you're having one side, you rationalize with one side, and then you end up with 2 divided by 2. I hope that is clear, but you should not have a side in the denominator. So you need to take note of that. Then angles in pure mathematics must be strictly to 2 decimal places. Then price indices must also have a minimum of 2 decimal places. That is what is advisable. But most marking bodies have pushed this to 3 decimal places, which is very okay. Then the Spearman's correlation coefficient must be in decimal places. It must not be in fractions. Reason being, if you look at the Spearman's table, you don't see any fractions there in the logbook. So everything in the Spearman's correlation must be in terms of decimal places. You cannot get a naturalist mark if you put your answers in terms of fractions. So you need to take note of that. And then the method is present in your logbook. So some of you fail to properly substitute the variables into that formula. Now if you have to look at the precise and clean work, we are going to start with not using more than one approach when you're approaching the questions. Now here we are giving final touches. Some of you are too stubborn, especially in pure mathematics. You give method 1 and method 2. Do not wiseacre here. If I tell you do that, the whole question is going to be terminated, because that's rubric infringement. So make sure that you use one approach you are most appropriate with, or you are most suitable with, to attack a specific question. So that is clear. And then for each and every question in mathematics, every question must carry its own page. Do not combine more than 2 numbers on a certain page. Some of you who are submitting in your work to me about the other mock body, I saw you are presenting more than 1 number on one page. So if at all you're having your page like this, you make sure that number 1 is on its page. Even if it's 3 lines, number 1 must be on its page. Then you open another page, you write number 2. You also write number 2 on its page. Then you open another page, you also write number 3. UNEB provides, you pay for these examination papers. So writing one number on one page allows you space. If at all you have done a mistake and you're going through your work, you can come and then you can cross. You cross using one line. You can cross this number where you made a mistake, and then you repeat it on the space that you left below. But if at all you write 2 numbers on the same page, you may not have the privilege to do this. So you make sure that you present every number on its own fresh page. Now when you go to section B, if at all you have in part A and part B, it's very okay to present them on one page. This is very okay, for as long as it's one number. Don't present 13A and then 13B on one page and then add another number on the same page. That's not allowed. Every number should be started on a fresh page. But part A and part B existing on the same page is very okay. Now cross with one line in case you have done a mistake. Do not overcross your work. You simply cross with one line. If at all you don't want to cross your work, you simply write the word omitted. And then you repeat your working. Now for applied mathematics, you are supposed to read the question twice, and the reason why we advise this is because the accuracy in applied mathematics is placed at the end of the question. So some of you panic, especially with normal distribution and NRM. We tell you that to 3 decimal places, that your answer must be to 3 decimal places or to 3 significant figures. So some of you have failed to distinguish between significant figures and decimal places. So you read the question twice and you understand the accuracy the question requires, and then practice the difference between significant figures and also decimal places. Then in mechanics, without units, no marks are going to be awarded for your working. So you make sure that you include the units. And for mechanics number, before starting at tackling the question, you make sure that all the units are uniform. If you're having meters and centimeters, you make sure that all the values are converted in terms of 1 unit. That's the first thing you need to do before you start your calculation or before you even draw your diagram. So after ensuring that all the values are in terms of 1 unit, 1 SI unit, then you may proceed with the calculations. Now finally we are going to be looking at the selection of the numbers. So when you are saying that, select first and start with what you know best. So with this I mean that when they are marking your paper, the examiners mark different numbers, and if at all the next examiner finds that you are failing the first numbers that you did, it gives the examiner an impression that you don't know what you're doing. So with that, if at all you are very conversant with number 12, you make your first page to be number 12. If you are very conversant with number 5, you make your first page to be number 5. For as long as you put each number on a fresh page, you start each number on a fresh page. So avoid rubric infringement. By this I mean that do not do more than the required numbers. So you're required to do 5 numbers in section B. If at all you do more than this, we shall count the first in the order of the arrangement of your papers. We shall count the first 5 numbers that you did, and then however much marks you scored on the final numbers, those ones are going to be neglected. We shall count the first 5 numbers you did, and then we ignore the numbers that are on the last page. If at all you have done rubric infringement, and sometimes it may lead to a -10. -10 marks if at all the chief examiner does not inspect your paper. So avoid doing more than the required numbers that are required in the paper, and this is very evident with the Uace students. Now when it comes to equipments that you're going to be using for the examination, have the items ready 3 days before your papers. And with this I mean that you need to practice with the calculator. You need to understand which buttons are hard to press. You need to understand what are the issues the calculator you're having is facing. Do not borrow the calculator one day to your paper. Have it 3 days and practice with it. A standard paper, seeing how it will disturb you or seeing the issues you may face with it in the examination hall. So for that, we are going to end the facilitation program here, and then the issues or the inquiries are going to come on the Zoom session. For those of you who subscribed who registered for it, we are going to have a Zoom session to make clarifications on the areas that you have not understood properly under this facilitation. So share the information to all your classmates and ensure that everyone is properly guided before he or she sits for the final paper. So this video has been presented by Better Days Learning Platform on YouTube and then by Mr. Algebra. So we meet in the next session. Success in your journey.